redundant instruction elimination. Redundant instruction elimination. The second is dead code elimination. Sorry, it's not dead code. It is unreachable code. Unreachable code elimination. Unreachable code elimination. The third one, flow control optimization. Flow control optimization. The fourth one, algebraic simplification. Algebraic simplification. And the fifth is use of machine idioms. Use of machine idioms. This is again an important topic. Peephole optimization. Redundant instruction elimination. Second is unreachable code elimination. Third one, flow control optimization. Fourth one, algebraic simplification. The fifth one is use of machine idioms. Now we will focus on the first topic. What does it mean by redundant instruction elimination? See, these are all actually high-level English statements, but when you just go on and deeply introspect that, it is actually a simplified statement. Okay, what is meant by redundancy? If you have a copy of a statement, that is called as redundant statement. Are you able to understand? Okay. Now, technically, it has been used as redundant. Now, I will go here. I will explain you what is meant by redundant instruction. Okay. Redundant instruction elimination. Removal of replicated instructions. Removal of replicated instructions. Removal of replicated instructions. Okay. Now, what is meant by replicated instruction? Let us assume that I write the assembly level code in 8086 version, 8086 version, not 8085 version. Okay. Now, what is the difference between 8085 and 86? Say for example, when I write MOV A comma B, okay, if B is actually getting stored in A, if B is actually getting stored in A, then it is called as 85 version. Then it is called as A085 version. Okay. Suppose if it is A is getting stored in B, vice versa, then it is called as A086 version. Okay. Now we are actually following this version called as 8086. Okay. Left and right operands. Okay. If the right operand is getting stored in the left operand, then it is 8085. Okay. If left operand is getting stored in the right operand, then that is called as 8086. Now we are using 8086 version. Okay. Say for example, I have a statement called as MOV X comma R1. MOV X comma R1. Now what is getting stored in what? X value is actually moved to R1, register 1. Okay. Now once again I write MOV R1 comma X. R1 value is moved to X now. Okay. If now closely introspect these two instructions, whether both will be having the same value or not. Both will be having the same value. Okay. Now X value is moved to R1 and R1 is again moved to X. Okay. So there is a redundancy in the instruction. So in this case, I can remove one instruction now. Okay, possibly try to remove the second instruction. So remove the second instruction. So what will be the answer? MOV X comma R1. That's it. If there is a redundancy in the instruction, remove that. So this is the first step. Clear? Now the second one is called as unreachable code elimination. Unreachable code elimination. Unreachable code elimination. What is meant by unreachable code elimination? I will illustrate with an example. Okay, if a code does not execute at all in your instruction, there is a possibility the code will never get executed. Am I right? Okay. Now such code is called as unreachable code. I will give you a classic example for this. Listen here. If code does not execute at all, if code don't execute at all, then it is called as then it is unreachable code. Then it is called as unreachable code. Okay, you write your own examples. Okay, now understand the concept, write your own examples. I will give you, say for example, I make x is equal to 0. I make x is equal to 0. Okay, now I make a statement called as if x is equal to 1, if x is equal to 1, I make y is equal to y plus 10. Okay, now what is the value of x now? 0. When condition will get executed? When x is equal to 1. So this code will never get executed, am I right? This chunk of code will never get executed. Are you able to understand? So this code is called as unreachable code. The entire code fragment is called as unreachable code. Okay, eliminate this by replacing that by x is equal to 0. That's all. This is called as unreachable code elimination. What is the other way of doing this? I will write another piece of code. You tell me which is called as unreachable code. Am I right? Shall I write another code here? Unreachable code. You tell me which is actually unreachable code. Okay. See here, I'll go to this next example. I make a function called as fun. Again, it's a hypothetical function. So return 1, a equal to 10. Now, which is unreachable? Exactly. So once the statement function is returning back, okay, this actually does not carry any sense with that. This will never get executed, isn't it? So this has to be changed as fun return 1. That's all. That's it. Eliminate that. Writing a code which does not execute at all is an inefficient process. Are you able to understand? Such kind of code should not be there. Okay. So this is called as unreachable code elimination. Now, the third one is called as flow control optimization, isn't it? What is the third title? Title number? Flow control optimization. So flow control optimization. So what is flow control optimization? Listen carefully. I actually try to make multiple jumps. Okay. So whenever you try to do anything, most priority wise, you just give priority to 3 address code. Okay. If you are not able to perform in 3 address code, then go for high level code. Okay. Now see here, in this case, flow control optimization, I just make here, so go to L1, the first jump. Go to L1. Okay. Now, after this, I make L1 is equal to go to L2. Okay. Now, L2 is equal to x is equal to x plus 10. Since this is a procedural oriented programming, we will start our execution from top to bottom. Okay, so first statement, go to L1. Control will be transferred from L1 to this place. Okay, now in L1 what is that? Go to L2, another jump. L2 will be transferred to this place, and then finally you will execute x is equal to x plus 10. Okay, now finally which is getting executed now? X is equal to x plus 10 is getting executed, am I right? Okay, so why which jump is unwanted jump here? L1. L1 is actually unwanted jump. Okay, directly instead of making this L1 here, I can directly jump to L2 and execute that, isn't it? Okay, so I transform this as go to of L2, then go to of L2 here. L2 will be x is equal to x plus 10, and this is L1. Forget about this one. Instead of jumping to L1, directly jump to L2. So top to bottom it will come over here and this will get executed, and rest of the things are meaningless statements. No need to make two jumps. Instead of that, change to only one jump. You know, directly you can write it, but here this is actually has to be executed in stages. Loop optimization and flow control optimization alone, for this alone, this is okay. You can directly write x is equal to x plus 10. But if you write x is equal to x plus 10, where is flow control? Clear? Clear, ma? Are you able to understand? Okay. So this is called as flow control optimization. Unnecessary jumps has to be eliminated. Okay. Shall I go to the next one? So the next is called as algebraic simplifications. So what is algebraic simplification? If an expression value does not change, such kind of expression has to be removed. That is called as algebraic simplification. Say for example, if expression value does not change, remove it. Okay, now I'll give a classic example for this. Okay, x is equal to x plus 0. Any relevant in this statement? No. I try to add 0, x value remains as it is. Okay, now y is equal to y multiplied by 1. You will get the same value of y. Are you able to understand? Okay, z is equal to z divided by 1. I will get the same value of z here. Are you able to understand? Okay, all these three statements does not change the value of x, y or z. Are you able to understand? In this case, eliminate all the statements. Eliminate all the statements. This is called as algebraic simplification. Okay. Now, algebraic simplification also has one more subtitle. Okay. That is called as reducing the strength. Reducing the strength. Reducing the strength already we have come across in the previous title. What is meant by reducing the strength? Replace the high precedence operator by low precedence operator without changing the value. Okay, say for example, shall I write like this? Let us assume x is equal to 4. Okay, I write x exponentiation of 2. What does it mean? This is equivalent to x squared. Am I right? This is exponentiation symbol. Okay, now what I have to do is I should get the same answer for x. Okay, by replacing this exponentiation symbol. Is about a low precedence operator. You have to replace by a low precedence operator. How will you do that without changing the value? Any idea? X is equal to 4. What will be the x squared here? 4 squared is 16. But I want to replace this high precedence operator with low precedence operator. Can I write x plus 4, x plus x? No. X plus x is actually 8. It will not result in the same value. So now, when it is an exponentiation symbol, I can replace like this, x star x. Okay. Exponentiation have high precedence than multiplication. So this is called as reducing distance. This is called as reducing distance. Clear? This process, entire process is called as algebraic simplification. Clear? The last one. The last one is called as use of mission idioms. Use of mission idioms. Okay. Again that is a jargon. It is part of idioms and phrases. Okay. What is meant by idioms means it is called as replacing by a mission code. Replacing by a short form is called as idioms. Okay. Now see here, let us assume that replace high level code by short form of mission instruction. Replace the high level code by short form of mission instruction. Listen carefully. Now, I equal to I plus 1 is a high level code. Okay. I equal to I minus 1 is a high level code. Now, how will you replace that with a short form of it? Okay. How will you replace with short form of it? See here, this can be transformed as. Okay. I said that it is mission instruction. Replaced by mission instruction here. Mission instruction means I can write INCI. That means increment I. This one can be replaced by increment I, and this can be replaced by DECI, decrement I. These are all actually part of optimization techniques. Okay. So what you have learned today? One is loop optimization. Another is called as peephole optimization. Last class you have learned about principal sources of optimization, basic blocks, flow graphs, and how to construct a basic blocks from high level statement. Okay. How to construct a flow graph from basic blocks. Clear? So that's about this one.